Lesson 867, Scatterplot City, Observing More Patterns in Scatterplots. In this lesson, you'll use a scatterplot to decide if two variables have a linear association and make connections to what the data represent. You'll also pick out clusters in data and make connections to what the data represent. All right, we're on page 84 in your notebooks. And I think it's actually going to be more helpful for this lesson to take a look at the notes before you do the activity, just so you have a sense of what it is that you're trying to find and what you're trying to see. So our two learning goals include using a scatter plot to decide if two variables have a linear association, we've been talking a lot about linear associations, but not all associations are linear. And I don't have a lot of room here, so I'm going to leave out the part where I say, and make connections to what the data represent. But I do want to mention picking out clusters in data. Pick out clusters in data. I should have capitalized that like I did linear. Those are the two important features of our scatter plots today, whether they're linear and whether there's clusters in the data. And I'll go ahead and write it here. Make connections to what the data represents. All right, let's get started. Sometimes the points in a scatter plot show an association, and sometimes there's no association. And sometimes the association just isn't linear. So we're going to take a look at two scatter plots here and make some decisions about whether they're positive, negative, or show no association, whether they're linear or nonlinear, and whether they have clustering. So let's take a look at this first one. Now, as I'm looking at these dots, as I move to the right, or as I go up on the x-axis, I also go up on the y-axis. So as x increases, y also increases. And that helps me determine whether there's a positive association, a negative association, or no association. We've talked about this before, but let me just remind you. Positive means that as x increases, y increases as well. And that's the situation that we have here. A negative association, just to remind you, means that as x increases, y actually decreases. And that's not our situation here. And no association means that there's just no relationship between the two. So I know it's positive. As x is going up, y is also going up. That's what this pattern shows. What I want to talk more about, though, is whether something is linear. Now, we've made some scatter plot lines of fit, and I'm just going to use a nice clear ruler here to try and draw a line that fits my data. And you'll remember that I want it to kind of mimic the same slope as the data, and I want to pass my ruler through the middle of the data so that about half of the data values appear above and about half appear below. See how I did? Oh, not too bad. So got the slope, and it's passing through the center of the data. And since I was able to do that pretty effectively, I'm going to call this a linear relationship. I think this is going to make more sense when I try it again in the with the other scatter plot in a moment. And then finally, let's take a look at where there might be clusters. And it might be helpful to define what a cluster is. It's a grouping of data that's visibly separate from the other data points. A grouping of data visibly separate from other data points. And it looks like in this set of data, there's maybe 3 clusters. Sometimes you have to use a judgment call about as to where those clusters are. But what you see here is kind of a gap between these pieces of data, these pieces of data, and that gap indicates that we've got some clusters. So I have a bunch of data that's clustered here, and then a little gap, and then some more data that's clustered here, then another little gap. And I'm just going to go ahead and smush all these together, but my judgment's making me think, should I smush these into 2 or just 1? I'm going to just use my judgment and make them 1. So these are all clusters of data. Looks like I have 3 of them. And you can see the gaps between those clusters. So I'm going to say that this is with clustering. Let's take a look at this next set of data. And maybe it'll be a little more clear how to tell whether something is linear. But let's start with whether this association shows a positive relationship, a negative relationship, or no relationship. I'll use red this time. Well, as x increases, it looks like the y values decrease. For example, here I have a small x value but a high y value, and here I have a high x value but a low y value for that coordinate. So as x increases, y decreases. But let's talk now about whether this is linear. Now I'm going to try to make a line of fit again, and this is a little easier if you have a clear ruler like I do. But I'm going to take a look at this data. I'm going to try to approximate kind of the slope of my scatter plot dots, just like I did before, and then pass my ruler between all of that data. Let me see if I can do it. Okay. So I think I've got about half of the points above and half of the points below, and I'm going to try to make a line. I'm going to make this a dashed line because I want to make a point here. And the point that I want to make is that as I'm trying to get half of the data above and half of the data below, I can see that in the middle of the data here, here's one end of the data, here's the other end of the data. In the middle of the data, it kind of sits just on one side. So really, a curve would probably fit this data better. There's some relationships that are a curve. But what lets me know that this is nonlinear is that the middle of the data sit on one side of the curve. I'm sorry, the middle of the data sit on one side of that line. So that's an indication that a curve would be a better fit. We just have to know whether it's linear or nonlinear. And if the data in the middle fall just on one side of that line that you're trying to make, we can call that nonlinear. Now, I've messed it up a little bit here, so it's hard to tell whether there's any clustering, but I don't see really a lot of gaps between the data. All the data seems pretty evenly distributed. So I'm going to say that this does not have any clustering. I'm going to say no noticeable gaps in the data. So in the activity today, when you get to it, you're going to be asked to make decisions about whether the data is positive or negative, whether it's linear or nonlinear. And you can tell whether it's nonlinear if the middle of the data is pushed to one side of that line you're trying to make, and whether it has clusters or doesn't have clusters. And if it has clusters, then there's probably gaps, noticeable gaps in between those clusters. All right, let's move on. We're going to draw some scatter plots with these features that we've been talking about. And I also want to think of examples of data that might have that relationship. All right, let's start with, jump a little bit here. Drawing a scatter plot that shows no association. We saw above a scatter plot that had a positive association, x increased and y increased, a negative association, when x increased, y decreased. You should probably have an example where there's no association. Let's go ahead and do that. So let's include at least 10 points in our plot. Just so we can see clearly whether it has an association. So how many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9. I actually have 11 there. So if that's my scatter plot, if I tried to fit a line to that, I mean, my first step would be to try to match the slope of the data. And I really can't tell what that slope is. It's just as likely that it would be negative as positive. There's no association between those data values. Now, let's give an example of something that might have absolutely no association. So let's make X the hours of babysitting. Okay, so what would be a relationship that wouldn't have anything to do with each other, where it wouldn't matter how many hours of babysitting I had? The other variable wasn't dependent on this at all and showed no association. So let me try and think. The hours of babysitting and I'm wanting to say how much homework I have, but I know some people would relate those two. How tall my sunflowers are. All right, sunflower height. So let's say we have all these babysitting gardeners and each person is asked, how many hours did you babysit and how tall is your sunflower in your front yard? How many hours did you babysit? How tall is your sunflower? All these people were asked that information. And I hope you can understand that the more babysitting you do has no influence on how tall your sunflowers are. You'd really have to work at making a connection between those two things. So this is an example of something that has no association. Let's do the same thing with these directions. This time we're drawing a scatter plot that shows a negative linear association. Oh, with clustering. All right, let's try and get all those things in. And again, let's make sure we have at least 10 points. And we want clusters this time. So I'm going to leave a gap between my between all my data points. So if it's negative, I know I want it to decrease from left to right. If it's linear, I know I want it to kind of fall along a line. And if it has clusters, I know there's going to be gaps. So I'm going to make 5 pieces of data there. I probably didn't leave enough space here. And then there. Okay, I'm going to call this a gap. I was a little hasty in placing my dots earlier. So there's my negative linear association. My line passes through the middle of my data values, and I don't have the middle of the data kind of clustered on one side. And I'm going to say I have 2 clusters and a gap in between them. It's like a chocolate chip cookie. And since I can, I'm going to go ahead and make a line of fit just so we can see that it has a clear negative association. While we're here, though, I want to do that same thing. Let's think of something where when one thing increases, another thing decreases. Okay? So I'm going to set us up. Let's make X decades from the present. So this is in 1 decade or 10 years, 20 years, 30 years, 40 years, 5 decades or 50 years. So this covers the next century. X represents the decades from now. Can you think of anything that is going to decrease as the decades increase? Can you think of anything that will go down over the next few decades? I'm going to give you a moment to think so I don't rob you of your thoughts. Think of something that will decrease over the next 100 years. Go ahead. All right. I'm thinking about climate change, and I'm going to say the depth of glacier ice. I actually visited Glacier National Monument a few years ago, partly because I knew that those glaciers were melting away. So the depth of glacier ice is decreasing as the decades increase. It's a little bleak to think about, but that's an example of one thing increases while another thing decreases. And you should be able to come up with examples like that. All right, well, to finish up, what's a strategy you can use to decide if two variables have a linear association? Well, the strategy I would suggest is what I mentioned earlier. Use a clear ruler to see if you can position a line through the middle of all the data values. To position a line of fit. And if the middle of the data sits on only one side of the line, then it's probably not linear. The curve would fit that data better than a line. All right, so lots of vocabulary today, linear and nonlinear, clustering, and with clustering we talk about gaps, and positive and negative relationships you already knew about. So we use scatter plots to decide if two variables had a linear association and pick out clusters in data to make connections to what the data represents.